Welcome to the 2.7 presentation of Geometry Chapter 2 here at the GoPro AJ channel. To start off the video, we'll begin with inductive reasoning. And that inductive reasoning is a process of identifying a pattern based on data. For example, if I notice that light statistically makes the weather warmer, so that means that when the sun's out, I can infer that it'll be warmer out.
Alright, the second part of Chapter 2 is statements. To start out, I will tell you the definition of a conditional statement. A conditional statement is an if-then statement. You may remember this as P then Q. For example, if I turn on a light switch, then the lights will come on. The lights won't just come on by themselves. I have to hit the light switch, then they will come on. So it's an if-then statement. Second thing to remember is a truth value. That is if the statement is either true or false.
Right. The negation is the statement, but P is the opposite of the statement. A conjunction is two or more statements, but they are connected by using like or as. The opposite of that is a disjunction, which connects two statements by using or.
So there are four different kinds of statements. The first one, as I already kind of told you, is conditional statement. That's an if-then. So for example, we have P to Q. What this means is that if I open a bottle of water, then water will come out. But then, as we have next, is the converse statement, and that is when you exchange or flip-flop the two letters. So then we have Q is P. So then, if water comes out, then the bottle is open. Up here, as I said before, conditional statement. If I open the bottle of water, water will come out. Converse statement, if water comes out, then the bottle is open.
Next thing you need to know is something called a biconditional statement. And what that is a statement whose conditional statement and its converse are both true. And it only contains the phrase if and only if. An example of this would be two lines intersect at 90 degrees. That can only happen if they are perpendicular. So if and only if they're perpendicular, they form a 90-degree angle. The next thing you need to know is something called deductive reasoning. And that is using facts and data and expected properties to figure something out. So it's like what Sherlock Holmes did. He used everything he had at the moment to connect it all together. So if P equals Q and Q equals R, then P equals R. So like an example of that would be, so if I'm in the circle and the circle is in a square, then that means I'm in the square.
Alright, so next is an inverse statement. An inverse statement is when you have P then Q, but it's when you make them both negative. And when it's both negative, when it's negative, you put a little squiggly line in front. So a little squiggly line, little note, I guess squiggly line like that would be not allowed or negative. That's what makes it negative. So for an example, when you have this, is that if I do not live in the U.S., so I do not live in the U.S., then I do not live in any states. So then I do not live in the U.S., then I cannot live in any states in the U.S. So next is a contrapositive. A contrapositive is just like this, but you flip-flop them. So what this means is that you have the Q and the P again, but it is a negative with our little line again. So this means that the U.S. is over here. So if I do not live in a state, then I do not live in the U.S. That's how it goes. So you just got to flip them back. They're both still negative, but you just flip them. So next, we move on to reflexive property. A reflexive property is pretty much when A equals A. Or how it goes is symmetric property follows that it means that if A equals B, then B equals A.
Next up, we have some theorems. First off, we'll start with the congruent supplements angles theorem. This means that if two angles are supplementary to the same angle, then these two angles are congruent. Next is the congruent complements theorem. So that's if two angles are complementary to the same angle, they're congruent. So if I have a 90-degree angle, and I draw a bisector in the middle, and they're both complementary to the same angle, that means that that's a 45 and that's a 45. So these are going to be congruent.
Alright, so next is the transitive property. The transitive property kind of plays off the reflexive property, but just has a little bit more to it, and just a little bit of a spin-off. So for this, we have to know that A equals B. And if A equals B, then C equals B, then we know that A equals C. If you kind of follow me there, so we know that A equals B, and if C equals B, so it means that we know that C is equal to A. That's how it goes. So the final one is substitution property. Substitution property is when we use the last one, where a transitive and reflexive property, and just use it in substitution. So for example, if we know that B equals 17, and we have an equation that says A plus B, or A plus 17 equals question mark, well, we already know that A equals B. So we can finish this out by doing 17 plus 17 equals 34. So in an equation, if you have A and B, and you know that A is equal to B, then you can just substitute A out and put B in there, because you know that they're equal to each other. Alright guys, thanks for watching. I hope you enjoyed Chapter 2 Geometry. Make sure to like and subscribe, and I hope you enjoyed. See ya!